Okay, good. So now we're going to get back to our Solos model, okay? As we have discussed before, Monday, Solos model is quite powerful. It tells you that, population growth can be a good thing because you have increase in population, increase in labor, but you increase too much, there will be a problem. So that's one of the reasons that in 1970s, Taiwan, okay, we have family plan, okay? You say family plan, but honestly, it is trying to tell you not to have too many babies. And, so at that time, our ideal number is 2, okay? Basically, if every family has 2 kids, that means you can replenish, to keep the population stable. But unfortunately, it's too successful. So now a lot of people, there are several economic concerns because housing are too expensive, and education is another great expense. So actually now people get married very late, and on the other hand, they have fewer babies. So that's so now we are not worrying about too many people. We worry about population aging and too few kids. Okay. So as we say, we have a very special equilibrium. I is equal to S, that's investment is equal to saving, and also equal to this, okay? This is depreciation rate, okay? So I is equal to S. It is called equilibrium. And I is equal to delta K, that is steady state. So if we have 3 things together, it is a steady state equilibrium. Okay, so let me give you a general picture here. And now we're going to get little k, okay? So what is little k? Then we should. So what is the difference between little k and k? What is the big K? And what is the little k? This one is total capital, okay, the whole amount of capital. This is capital per person, okay? And so this is little y, means output or income per person. So here, this is SFK, okay? And here you have delta K. Okay, questions? So now what I'm going to tell you is that, based on what we have discussed before, if you have depreciation rate goes up, okay? Depreciation rate goes up, what happened? It is something like this, right? So let us say it is, oops, delta 2K, okay? So what happened? K goes down, okay, and Y goes down, okay? And because we don't mention anything else, so what does that mean? That means big K also goes down and big Y also goes down. So this is per person capital going down. This is per person income or per person output going down. And total amount of capital going down. And total amount of production or income go down. What does that mean? If you have increase in depreciation rate, the economy is poorer. Everyone has less capital, has less money, has less output, has less income, okay? And what about here? If N goes up, right, that will be the same thing, okay? Because the same amount of capital has to be distributed among more people. So little k goes down, y goes down. Okay, And this time, when we mention this, okay, this time when we mention this, what do we say? We say, because population is going up, right? Population is going up. So you may have more people to compensate the proportional drop in terms of per person capital. So we don't really know what happened to total amount of capital and total amount of income. Okay? And when G goes up, right? The same thing. Okay? This one, per person capital, per person output will go down. Okay? But again, because the economy is going up, okay? So even though per person capital, per person output is going down, we don't quite know about big K and big Y, okay? And what about saving rate? If saving rate going up, okay, little k, little y will go up, and also big K, big Y, will go up. Okay, questions? And let's deal with saving rate again, okay? So here you have something like this, little k, little y, and you have S times F little k, okay? And this is delta little k depreciation. And we say saving rate goes up, right? Saving rate goes up, so you have S2 times Fk. So what you get? You get increase in per person capital and also increase in output, right? So going to the right and going up. Okay, so definitely this is different from Keynes, right? Keynes, what did he say? He said, if you really want economic growth, you need to have what? You need to have more consumption, right? And if you remember the expenditure multiplier, right? Expenditure it is equal to 1 over 1 minus MPC. And that is equal to 1 over MPS. So the more you save, the less income you're going to get out of it. Okay, the more you save, the less income you're going to get increased. Okay, so this is different. Soto model say saving is good, but Ken say consumption is good. Okay, so that's the difference. Okay, questions? Now we are going to get to the golden rule, okay? Golden rule. So what is golden rule? Everyone good with this? I'm going to erase it. Okay. So here you have little k, little y, and you have f, little k, and here you have delta k, okay? Okay, so what do we want? We want to have more consumption to people. As you know, sorry, this is, okay, going to be saving, and here is going to be consumption, okay? So, what's going on here? The golden rule, there's one point that you need to be careful. Golden rule means we want people to have more consumption. Okay, so consumption basically means a benefit to people. Okay, the more you can consume, okay, the better off you are. Okay, basically that's the idea. And so here that's the production function. Production function is equal to income, right? And your income can be divided into two parts. One is C and one is S. Okay? So in this case, you want to make sure that, okay, the income level is as high as possible. Okay? But you also know that we have to make sure we are in a steady state and also in equilibrium. So investment has to be equal to delta K, that's the depreciation, and then that investment comes from your saving. Okay, so to make sure that we have the highest level of income and also consumption, what would you need to do? You will need to produce at, okay, this is production function, your income, right? And so make sure that there is a vertical distance, okay, the largest vertical distance between production function and the depreciation, okay? And so here, this part of it is saving, right? Why? Because you need to make sure it is in equilibrium and also steady state. And the rest of it will be consumption, okay? So what does that mean? That means this line, okay, has to be parallel to this depreciation K, okay? And so what does that mean? And this line has also to be tangent, okay, tangent to the production curve, okay? If it is tangent to the production curve, what does this mean? It means the slope, okay? The slope of this production function has to be MPK and it is equal to delta, okay? Okay, so hold on, let me. So this line has to be tangent to the production curve, tangent, T-A-N-G-E-N-T, tangent. So, Huang Jiaxuan, what is tangent? Yeah, you can say that, but you know, basically that means. Right, exactly. Okay. The slope of the tangent is, okay, MPK, right? Because it's the tangent of the production curve, right? So it's MPK. And what is the slope here? The slope is delta, okay? So to make sure people have the maximum consumption, MPK has to be equal to delta, okay? And now we can add more, because suppose you want certain population growth, you need to have more people, okay? Then you have to consider those people too. So the golden rule with people, population growth, it is MPK equals delta plus N, okay? As you know, if you just want to make sure that people, you know, have the maximum production, then MPK is equal to delta, that is enough. But you know, if you want to account for more people in the society, then you have to gear up, means you have to increase productivity. Okay, so that's a little bit more difficult there. Okay, so basically that is the idea. Okay, so there are a whole bunch of variables here. Okay, delta, depreciation rate increase, little k goes down, little y goes down. Population rate goes up, little k goes down, y goes down. Economic growth rate goes up, okay, little k goes down, y goes down. Saving rate goes up, little k goes up, y goes up. Okay, so these are a whole bunch of variables and what's the impact on the economy and also the production level. So these are all very important things, okay? And then we have another rule, golden rule. If you want to have maximum consumption, you want to make sure that the distance between production function and the depreciation is the largest, so that the MPK, the marginal product of capital, has to be equal to depreciation rate. And if you consider population growth, then that's additional one that you have to put there. Okay, questions? Okay. Now we're going to get to another model. It's called Harrodoma model. Harrodoma model. Harrodoma model is quite specific, okay? Basically, this model is not quite as good as the Soto's model because its prediction is not quite as correct as you like. And basically, the point is based on Keynes' model. Okay, even though it is based on Keynes, but the conclusion is also opposite from Keynes. Keynes' model say if you want to have economic growth, you need to have what? You need to have consumption. But here, it is different. And it takes a little bit time for me to get to that. So I think we'll just take a break earlier, okay?